Hi, my name is Emily, and here's my presentation for the least squares project. So, the data set that I used was from 15.2, and it was just the question 40. And the first problem asked to show that for each data point, basically show the corresponding point on the line has the y coordinate b plus m times xi. And then we can see the lines show the distance between the data point and the y coordinate on the graph. Um, and you can calculate it by just plugging in the values for on the line. And then we can also see that the square of the vertical distance from each data point to the point on the line is yi minus b plus m times xi squared. And then we can see each component, how we get each component, and then the square of the vertical distance is here. And then that's shown by the area of these squares here. Okay, next we see that we can get this summation equation. And then if we take the partial derivatives for b and m, this is what we get if we use the chain rule. Okay, next we are trying to minimize the equation, the line. So we set each of the partial derivatives equal to 0. And then when we solve, this is what we get for each of them. Okay, and then in order to solve for b and m, we have to manipulate the equations like a system of equations. And as you can see, after a lot of work, we get this for b. And then for m, you do the same thing, solve. We have to do some manipulation with the denominators and factoring out the m, and then we end up with this equation for m. Okay, lastly, since we've solved for b and m, we can see that the formula works by plugging in numbers for these 3 points. And then if we plug them into the b and the m equation, then we get -1/3 equals b and 1 equals m. And then that makes the equation y equals x minus 1/3, which matches with the formula in the example problem. Thanks for watching.